API stands for Application Programming Interface, which is a set of protocols, routines, and different tools for building software application. API acts as a communication interface between software components, as well as by components I mean servers, computers, etc., allowing them to interact with each other. APIs can be used for many purposes such as retrieving data from a server, updating a database, or integrating different software applications. Now, to be able to do all of these functions, we need to have we need to follow a style to be able to actually define these methods. So one of those architectural styles is called REST. REST stands for Representational State Transfer. It is a software architecture style that defines a set of constraints to be used for creating web services. RESTful web services are based on HTTP protocol and use HTTP methods such as get, post, put, delete, etc. to manipulate resources. Now, if you want to, let's say, retrieve data from a server, you would use the get method and create an API using a get HTTP method. Similarly, if you want to create a resource on the server, you would call the post API. If you want to, let's say, update a database, you would call a put API, and maybe delete a resource, you would call the delete API. And there are many more such HTTP methods that you can use. So what is the relationship between API and REST? Well, REST is one of many architectural styles that can be used to design APIs. RESTful APIs are designed to be stateless, meaning that they don't store any client context on the server. Instead, the client sends all the necessary information with each request, and the server returns a response that represents the current state of the requested resource. There are many benefits to using RESTful APIs, including scalability, simplicity, and compatibility with different programming languages and platforms. And these RESTful APIs can also be easily consumed by client applications like web browsers, even mobile devices, and other software applications. Okay, so to build an API, we're going to be using the same server that we created in the last video. I'm going to link the video in the description, so do check that out as well before starting this. Now, to create the API, there's one thing that we need, which is called a router. A router in Node.js is nothing but a way to catch requests on a certain specific URL and send the response based on the request. Now, to do that, I'm going to be creating a router file called router.js. You can call it whatever you feel like. And I'm going to be again requiring the Express package. And I'm going to be creating a router variable, and this router comes out of the box with Express, and I'm going to be calling merge params true, and this specific parameter we're going to be using in the future videos, and I'll explain the use of this specific parameter as well later on. Now we have the router in place. Like before, we're going to be exporting it as a module so that we can use this router in other places as well. Majorly for this video, we're going to be requiring it in the application module, application file. Now, just to create a simple API, we're going to be using HTTP GET method, but there are other methods as well, which I'm going to be covering in future videos, like GET, put, post, delete, patch, etc. But for simplicity purposes, just to understand how this API works, I'm going to be using the GET method. And the basic way of doing it is router.get, and then I just need to define the URL for this specific router. So I'm going to be calling a ping, calling it ping, and then just creating a function. And here I'm going to be basically this function will be called once the user calls this URL. So I'm going to be we need to send a response here. And to do that, we're going to be calling the res object, res parameter dot status and basically passing in HTTP statuses here. So I'm going to be passing 200, which is okay in terms of HTTP codes, and then a basic send function with a message saying Pong. Now, whenever someone calls this URL, they're going to be getting this JSON as a response with a status code of 200. Just to cover these parameters as well, the first parameter in this function would be the request, and this will have all kinds of properties and functions related to the request that we're getting, like headers, payloads, etc. RES is basically response, and this is basically the response object, which has all of these functions, which is going to be basically containing everything related to the response that we're going to send after the user calls this API. And next is another function which basically lets you, rather than sending the response here, it basically lets you move on to the next function in the pipeline. I know it sounds a little complex, but we're going to be covering it pretty soon, and it's a very basic concept and it's really helpful in a lot of different use cases as well, like middlewares and stuff like that. But for now, let's just think about this RES object and use it to send the response that we want. Now that our basic router is done, we're going to be moving on to the application and requiring it. So to do that, we just require it like this and create a middleware like this. So app.use basically enables us to use this router file as a global router, and you can define whatever base URL you want. So for example, if I want to do v1, then at the end of the day the user will have to call /v1/ping. If it was v2, the user would have to call this URL, and we can specify different routers with different base URLs. This can help us in versioning in the future and stuff like that. But for now, I'm going to be just calling it as v1 router, and I'm going to be starting the server now. So if you remember, previously we created a script to start the server. We're going to use the same script, which is npm run start, and we can see that the server has started. So if now anyone goes to http localhost 3000/v1/ping, they should get the response that we have coded, which is msg:/pong. Now when we go to this URL, localhost 3000/v1/ping, as you can see, we can see the response that we configured, msg and pong. And if let's say we want to switch to some other URL, you can see an error code cannot get ping because we didn't define this URL, right? But you can internally go and configure ping without v1 and see the response as well. That's it for this video, and I'm going to be covering more complex APIs in the future videos so that you can understand different HTTP methods and how you can use these APIs to create a simple application as well.